When we measure intelligence, we usually test a person's grasp of mathematics or their mastery of language. But consider the cognitive ability required to read the intricate networks expanding beneath our feet. By strictly defining genius through equations and essays, we create a massive societal blind spot. We completely overlook the exact mental toolkit required to solve our most pressing ecological problems. This missing piece is known as naturalistic intelligence. It is the specific capacity to recognize, classify, and deeply understand the components of the natural world, from identifying shifting weather patterns to predicting the behavior of complex ecosystems. Knowing how to read a landscape serves as the core prerequisite for anyone trying to engineer sustainable systems in a changing climate. The scientific recognition of this skill took decades. It wasn't until 1995 that developmental psychologist Howard Gardner expanded his widely accepted theory of multiple intelligences to include it. Gardner observed that certain people possess an exceptional ability to classify living things and detect environmental patterns. He realized this capacity operated completely independent of traditional academics. It was an entirely separate form of human intelligence. Gardner's research formalized these observations as a specific cognitive ability, making nature-based pattern recognition a measurable academic metric. To see how this intelligence mechanically processes information, consider a student named Grace living in a farming community. While an average observer sees a green blur, Grace actively parses the scene. She isolates distinct plant species, logs bird calls, and tracks humidity. She applies this processing power to the dirt itself, tracking the specific correlation between soil quality layers and crop growth rates. Using those observations to recommend new planting methods for the school garden, crop yields drastically increase. Grace acts as an environmental data processor, actively extracting information to solve a structural problem. This replicable four-step process begins with raw observation of nature, immediately categorized into patterns. Step 3 requires ecosystem comprehension, where patterns become an interconnected web. That web drives environmental decision-making. Like a farmer altering watering schedules, the intelligence outputs actionable change. This cycle, monitoring environmental variables and adjusting inputs for specific results, is the same logical sequence used to manage sustainability systems on a larger scale. When applied at the macro scale, this cognitive process provides the analytical framework for the modern circular economy. In agriculture and forestry, agronomists rely on it to diagnose soil health, while wildlife managers study subtle animal behaviors to protect endangered populations and maintain regional food supplies. In the renewable energy sector, experts analyze shifting climate and weather patterns to optimize where and how we deploy our power grids. For instance, successfully building solar infrastructure across West Africa relies heavily on engineers who can accurately read and adapt to the region's highly localized environmental factors. Without professionals utilizing a high degree of naturalistic intelligence to guide these projects, these global industries simply cannot function sustainably. This cognitive demand extends directly into the spaces where we live. Urban planners and conservation scientists utilize their environmental knowledge to design green cities and minimize resource waste. They map out ways to weave natural systems directly into concrete infrastructure, ensuring long-term biodiversity and resource efficiency within high-density populations. This intelligence allows designers to align human infrastructure with the existing biological requirements of the planet. Solving our most complex environmental crises certainly relies on advanced technology, but it depends entirely on the human cognitive ability to step outside, observe the landscape, and read the patterns.